Hello there, chemistry students. Miss Heaton signing in. You may notice some additional music in the background today. I just read a study that shows that students in France who study with classical music on in the background as they're taking in a video lecture actually learn more. So we're going to try it out today. If you hate it or if you love it, let your teacher know and we will take your opinion into consideration. Okay, well today we're talking about molarity and dilutions. These are both terms that we're going to use to talk about how concentrated a solution is. So let's start with molarity. Molarity is represented by the big letter M, and what it means is how many moles of solute are dissolved per liter of entire solution. Remember that solute is the smaller component that's being dissolved, and the solution talks about both the solute and the solvent together. Later we'll learn about different terms that describe concentration, and they may be describing the solute and solution differently in terms of what we're dividing by and putting on top. So that will be important later. But let's focus here on molarity. Here we have 3 different containers, and we're going to represent the particles with moles. That's what those cute little furry animals are there. Find the molarity of each solution here. Well, in the first solution we have 2 moles of solute dissolved in an entire volume of 1000 milliliters. Now it does need to be in liters, so we'll divide by 1000 to get to liters. So that would be 1 liter. 2 moles per 1 liter. That would be a ratio of 2 molar. And we would need to put whatever chemical it was on the end. So it's 2 molar of moles, I guess. For the next one, that's kind of hard to see. We got 1, 2, 3, 4, 5, 6, 7 moles. I think we got 7. Actually, I think there's 8. 8 moles dissolved in 250 milliliters. That would be 0.25 liters because you divide by 1000. So you'll type in 8 divided by 0.25. That would be 32 molar. So that is really concentrated. And if you look at it, those moles look to be way more concentrated than our first mole sample. Okay, and our last one here, quickly count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's a lot of moles there. Hey, do you think this is going to be more or less concentrated than the other 2? Well, you can kind of look at it and maybe make a guess. And if we got 5,000 milliliters, that would be 5 liters. So that turns out to be 4 molar. So it's only twice as concentrated as our first one, because that was 2 molar. And it's about 8 times less concentrated than the second one. So molarity is just kind of a number that tells us approximately how strong our solution is. Let's do an example of a real chemistry calculation with this. So the example is how many grams of sodium chloride are contained in a 100 milliliter sample of 0.2 molar solution. So if we wanted to visualize this, we would have maybe 100 milliliters, which is going to be, let's see, divided by 1000, that would be 0.1 liters of solution. We want to know how many moles are in there. So how many of these pieces are in there if the solution has a concentration of 0.2 molar. That means there's a little bit less than 1 mole for every liter. So we'll plug it into our equation. Molarity equals moles over liters. Molarity here is 0.2. The number of moles is what we're trying to find. And the volume is 0.1 liter. So we will cross multiply and we'll get that x equals 0.2 times 0.1, which is 0.02, and we solve for moles. So that's how many moles of NaCl are in our container. Remember, a mole is 6.02 times 10 to the 23rd particles, so there's a lot of particles in there. Oops, that doesn't say the right thing. NaCl, there we go. But the question here was actually asking how many grams. So to do this, we're going to have to think back to what we already know. This is something you already know how to do. You know how to go from moles to grams, right? Because you know that you can use the molar mass. So using your periodic table, you'll find out what the molar mass of sodium chloride is. For NaCl, Na weighs about 23 and Cl weighs 35.5. So you add that up and you get about 58.5 grams per mole. Oh, hey, we're listening to Pandora, so there's a little ad there. Pause for a second. Okay, we got some music on again. If we keep doing this, I'm going to have to invest in some real good music. So we've got 0.02 moles of sodium chloride, and we know that 1 mole weighs about 58.5 grams. We'll plug in 58.5 grams of NaCl on top, and 1 mole of NaCl on bottom. And then we'll multiply across. 0.02 times 58.5 turns out to be 1.17 grams of sodium chloride. And if we look back here, we've got 2 sig figs versus 4 sig figs, so we'll go with the one that has less, which has 2 sig figs, so we'll need to round this to 1.2 grams of sodium chloride. Great, so that's molarity. Our next topic is to kind of compare molarities. And we could use 2 different words here. We could say that a solution is concentrated or that it's dilute, depending on how big its molarity is. If it's concentrated, that means it's got lots of solute. We may call it a stock solution if it's a standardized solution that you might have like in the back stockroom of the classroom. A solution will be dilute if it doesn't have very much solute, or if you could describe it as being kind of watery. Now, let's think about these 2 questions here for a minute. How could you make a concentrated solution more dilute? Well, there's a couple different things you could do. First, you could add water. You could water it down, because by watering it down, you're going to make it more watery. Another way that you could make it more dilute is to somehow remove moles. So we're making the number on top of our molarity equation. Remember, molarity is moles over liters. If we're making this top number smaller, or making the entire volume bigger, that's going to make the molarity get more dilute, make it smaller. Now, on the other hand, how could you make a dilute solution more concentrated? Well, you could add more moles, or you could get rid of some of the extra water in there. So maybe you could evaporate the solvent. Now, I'm going to use water and solvent interchangeably because typically the solvent that we use in this class will be water, but just keep in mind that anytime we talk about water, we could also be using a different solvent. Okay, well, let's talk about the process of dilution. This is something that we often do in the lab. In fact, I do it all the time when I'm preparing the labs for you, because we have concentrated stuff in the back and I don't want you to hurt yourself, so I dilute it for you. And so dilution is just a lab procedure in which a volume of concentrated stock solution is mixed with some volume of water or other solvent in order to make a more dilute solution. And you can calculate exactly how concentrated or how dilute a solution is, or how much you need of your stock solution, using some math, which we'll get into in a minute. But here's kind of a visual of what dilution is. So you take your concentrated stock solution here, and you take a small volume of it out. Now, you can't just take moles out, right? You can't just take out those particles because you can't see them in a solution. So what you do is you take a certain volume of that stock solution out, which contains the moles of solute that you want to have in your final solution, your dilute solution, and then you add enough water to get to the volume and concentration that you want. Now, using lab equipment, here's what you might see. These funny looking flasks here are called volumetric flasks, and these are often used because they measure a very precise volume. They only have one marking on there, and they're great for making dilutions because you can get the exact right concentration if you use the exact right volume of each. And then this tube here is called a pipette, and it is used to obtain a very exact amount of whatever you're using. So what you do is you take your stock solution, your concentrated solution, take a certain amount of it out, and put it into another volumetric flask. So that's the small amount of our stock solution. And then you could add your solvent, add your water, till you get to the desired volume that you're trying to produce. Here's the equation I was talking about earlier. So this is the equation for a dilution, where the molarity of your initial stock solution times its volume that you take out equals the molarity that you want at the end times the volume that you want at the end. And this works because the number of moles stays constant. You're not adding any more solute as you do the dilution. If you are mixing different amounts of solute together from different sources, you cannot use this equation. So let's try a calculation here. How many milliliters of 1 molar sodium chloride is needed to make 500 milliliters of a dilute 0.25 molar solution of sodium chloride? So maybe if we could draw a picture. Here we've got our 1 molar stock solution, so it's pretty concentrated. We've got a ton of it, right? And we want to make only 500 milliliters of a 0.25 molar solution. So that's going to be more dilute. We're only going to need a certain number of moles. So what we can do is call this our 1 and this our 2. And we'll plug into our equation what we know. We know the molarity initially was 1 molar, and we don't know what volume of it we're going to take, but what we're going to calculate is how much we're going to take out of here and put into here to make what we need. So we will do the calculation and find out. We'll solve for volume 1. We know that the molarity we want at the end is 0.25 molar, and the volume we want is 500 milliliters. Now you can keep this in milliliters or you can convert it to liters, either way. I'm just going to keep it in milliliters for now. So you'll do 0.25 times 500 and then divide it by 1. So when you solve for V, you get 125 milliliters. And what that tells you is that this amount here that we circled in red that you're going to take out is 125 milliliters of your concentrated 1 molar NaCl. And so what that means is to do this dilution, you'll take out 125 milliliters and put it into a beaker. But will that give you by itself what you want? No, that would still be a 1 molar solution. And we want to end up with 500 milliliters, and only 125 of it comes from our concentrated solution. So what we'll do is we'll add water to the rest of the amount to get to the 500 milliliters that we want. So we would then have to add in, a little bit of water to make it dilute. Whoops, that just erased it. Okay, we got one more calculation here to do. Why don't you try this one on your own? So hit the pause button, give it a shot, and then check back in. Okay, here we go. How could you make 250 milliliters, so let's draw that here, 250 milliliters of 2 molar HCl from a stock solution of HCl, which has a concentration of 12.1 molar. So we've got a ton of it, it's really concentrated, and we want to know how to make a dilute solution. So essentially we're going to take a small amount of this out, put it over here, so maybe that will be like this amount right here, and then figure out also how much water we have to put in to bring it up to the total volume that we want. So plugging it into our equation, M1V1 equals M2V2. M1 is 12.1. We're trying to find the volume. And the molarity is 2, and the volume is 250 milliliters. So since we're using milliliters, what we solve V for will turn out to also be in milliliters. So 2 times 250, that's 500, divided by 12.1, turns out to be 41.3 milliliters of 12.1 molar HCl. However, does that answer the question? It says, how could you make? Okay, so if we just said 41.3, we wouldn't be explaining how to make it. So you'd have to say, take about 41 milliliters, using sig figs, 41 milliliters of 12.1 molar HCl, and put it in a beaker or volumetric flask. And then add water. We can calculate how much water we would need, right? Because we want the total volume at the end to be 250 milliliters. So 250 milliliters is the final volume that we want. We're going to be using 41 from our stock solution, so the rest has to be filled with water. So that gives us a difference of 209 milliliters. So add water, 209 milliliters, to the HCl solution, and mix it so that the solute gets evenly distributed and you don't have a bunch of water on top and then solute on the bottom. Okay, so that would be your answer to the question. This is Miss Eaton signing out. Happy diluting!